Welcome back to eJournal Club, where we turn recent reproductive pharmacology research into 3 minutes you can use. A single tube of blood may one day flag preeclampsia before symptoms appear. But that promise rests on something far less glamorous than discovery. It rests on whether a laboratory can process hundreds of samples the same way every single time. Today's journal is Cell Reports Methods, and the paper is a high-throughput, end-to-end pipeline for extracellular microRNA biomarker discovery from human biofluids. Hakime, Chusal J. N., Srinivasan S. and colleagues describe a significant advancement in liquid biopsy standardization. Extracellular microRNA circulate in plasma, serum, and urine and have been proposed as non-invasive biomarkers for preeclampsia and other conditions. The authors note that extraction is the rate-limiting step. Manual protocols are reproducible but slow. An experienced technician can process only about 24 samples per day, a real barrier for large multi-center studies. Hakim Chusal and colleagues reasoned that an automated extraction protocol, paired with a systematically selected normalization strategy, could match manual performance while adding scale. Pregnancy itself would serve as the biological test of whether real signal survives. Plasma, serum, and urine were pooled from about 10 donors in each of 3 groups: healthy males, non-pregnant females, and third trimester pregnant females. Pooled aliquots were extracted using a manual comparator or one of 4 variations of an automated magnetic bead method on a Kingfisher Flex platform. Library preparation and sequencing were identical for every sample, so differences reflected extraction alone. 4 normalization approaches were then compared. One automated variation, which doubled the input volume, delivered the most balanced performance across all 3 biofluids with strong yield and high library complexity. Precision was on par with the manual method. It also lifted throughput to 192 samples per day. Notably, the highest yield variation, which concentrated RNA by desiccation, produced the lowest complexity. More RNA did not mean better data. Among normalization methods, DESEQ2 most effectively reduced technical variation while preserving biological signal. Comparing biofluids, plasma was the most reproducible, serum was moderate, and urine was highly variable. Placenta-specific microRNA, as from the chromosome 19 cluster, were consistently enriched in pregnant plasma and serum. These classified the pregnant state with near-perfect sensitivity and specificity. In urine, they were largely undetectable. The authors conclude that automated extraction with doubled input, followed by DESEQ2 normalization, offers a scalable and reproducible workflow. Plasma is preferred for the lowest variability, while serum remains attractive for pregnancy work because it expressed more chromosome 19 cluster microRNAs. The authors caution that pooled specimens were used, so inter-individual variability remains to be tested. Open question: if serum carries more placental microRNA signal, but plasma carries less noise, which biofluid should a preterm birth biomarker program choose? If this episode reaches 50 likes, we will do a deep dive on chromosome 19 cluster biology. Stay connected and grow together.